Isaac is the lead developer for cloud at a hardware deep learning startup. He also holds a PhD in chemistry, and so if you think about it, it makes sense that he uses a language called Elixir. He might not have found the alchemical formula for the Philosopher's Stone yet, but he already figured out how to transform Z code into Elixir NIFs. The talk is Zigler, Elixir, FFIs with Zig, and Isaac. The stream is yours.
Thanks for that perfect introduction. So I will be talking about doing FFIs with Zig. And this is kind of on the opposite end of the FFI spectrum from what Jakob was talking about. He's calling Zig down into something, and I'm calling something down into Zig. So most of this will be around a package that I wrote for Elixir called Zigler. And you can find the documentation here. HexDocs is the Elixir package manager documentation server. It also hosts the documentation for Elixir itself, and Zigler is the name of the package. And if you, in the demo, I'll show you how you can actually use this with Elixir itself and pull the package, yeah, we'll go from there. I guess the one funny thing is this will probably be the first Zig show where the Zig command line never gets called directly. Okay, so not everybody who uses Zig will know what Elixir is, so I'll give you a little bit of introduction about that. So what is Elixir? It is basically a new skin on the Erlang VM, which is called the Beam VM. And that was invented in the 1980s. It's a very high-level programming language. Dynamically typed, garbage collected, compiled, designed from the start for systems with high uptime and throughput. Basically, the story is a team at Ericsson was given 2 or 3 years to correctly build a programming language that would be able to handle highly concurrent telephone switching management software. And they really spent their time to try and get it right. And that is basically shown itself in the fact that the architecture and the basic concepts of the virtual machine have effectively been unchanged for almost 40 years now. And they're still valid, and it's an extremely performant programming language, a virtual machine, if you will. The important things were to have distributed systems and concurrency primitives baked in. There is something called the let it fail philosophy, which is jokingly, if you've ever seen the IT crowd, the solution for all technical problems is, did you turn it off and turn it back on again? And that philosophy is baked into all aspects of what you program in the Beam, and I call it failure domain driven programming. If you're curious about this, there's a great YouTube video called "The Soul of Erlang and Elixir," and you should watch that because it introduces you to a completely different programming paradigm than what you might be used to. So with having said that, it's almost like the opposite of Zig, but I think that's really good because they complement each other in important ways. And I'll get into that in the next slide. Specifically with respect to Elixir, it brings to Erlang a friendly algol syntax. It looks very Ruby-ish, which is influenced by the algol paradigm. Erlang itself is a Prolog syntax programming language, so it's pretty tricky for people to read. And since the 1980s, we've learned a lot about how to do systems engineering and teams of programmers. So it takes an opinionated stance on how to do concurrent testing. It's got documentation tools. It's got Lisp-ish metaprogramming. And one thing that might be interesting, so those are all collectively things that are sort of programming paradigms that have come about since the 1980s. So you can think of it as like a new skin. Like here are these things that we've discovered are great for programmers, and let's bring that into Erlang. And then there's also of interest to Zig programmers. there's this concept of comp time, and I actually kind of realized this pretty late into the project, that like Elixir and Erlang have this similar idea that you can run this code at compilation time, and I wasn't fully utilizing that in the Elixir programming language. And having worked with Zig, I was like, oh wait, I can do similar things back in Elixir. So that was a pretty good learning experience for me. So given that the properties of the beam, why do we need FFI, which in the beam world we call NIFs? Well, the first is that it's not a speed daemon. Remember, as I said, safety and throughput are the priority. So box types and garbage collections both incur a performance hit. In many cases, if you have stupidly parallel programs, that's really not a problem. But like sometimes you just really want like to do matrix multiplication or something like that. And if you want to do that, you probably should use some sort of FFI. Sometimes you might also need low-level operating system hardware access. So a priority for the Beam VM is to have cross-platform compatibility. Windows, Mac, and Linux all expose different syscalls. If you really want like a platform-specific syscall, you're not going to be able to do it in the Beam. There's no direct escape hatch, and so FFI is your way to do that. So why did I pick Zig? Well, I wanted something safer than C. So remember how I said that Erlang's VM is a failure domain driven development. So you have internally you have processes which are like services or threads, if you will, but they live in these silos where if you have a miscode or a crash in one of them, it will not bring down any of the other parts of your concurrently running system. When you use an FFI, that breaks that. The whole system is written in the CABI, and if you have a seg fault or a panic, the whole thing will come down, and you've effectively broken down the barriers between your failure domains. So you really do want something safe. Building NIF has a lot of fiddly bits, and I'll show you that in my demo. And the great thing about Zig is it's very easy to parse. Thank you, Andrew, for making a simple language. And I wanted my NIF code to live in line with Elixir. And the reason for that is to give you the ability to code review with ease. And if you have so a big thing that's happening in the Elixir community is embracing the idea that you can look at two versions of a library and immediately identify security regressions. And the motivation for that is stuff like leftpad, if you are familiar with the Node.js community, those sorts of things, so that those sorts of things can't happen. Or there's also another one, I don't remember the name of which, where it injected a crypto miner. So we want to be able to like diff our packages. And in the Elixir community, taking software bill of materials and full provenance of your code tool chains like really seriously. So as an example, there's another programming language where you can, which is the most popular one for FFIs right now in Elixir, where you have to use their package manager to import that code. So there's a level of indirection where it makes it difficult to like double check your work. But if your code lives in line with the Elixir code, then you can actually see, hey, here's the change that happened in our code, and it's easier to review it. And the last thing is that Zig is, I call it, say, aggressively unopinionated about allocations. The reason why this is great is because the Beam VM gives you a memory allocator that you can hook into, and you want to use this one because if you use this memory allocator, then the VM can keep track of all of your allocations, and the performance is better because you don't take a second trip to the kernel to do an allocation. And I think that, and I'm not sure about this one, but I think that the likelihood that you'll get cache invalidations is lower because it will put that allocated memory close to where it's being used. But somebody can check me on that and correct me if I'm wrong. All right. So personal motivation. So why did I embark on this path? Really, the biggest one was that I wanted to not call out to fping. So if you don't know what fping is, it's basically just ping, but designed for you to designed to be more scriptable. Since I do cloud VM deployments, you can imagine why I might want something like that. Zig offered access to the low-level socket functions, which are which you need to do ping. So ping is uses the ICMP protocol, which is actually sort of lower than TCP and UDP. Beam gives you very nice TCP and UDP constructs, but not anything below that. So I did wind up completing that project, but actually after the newest release of Beam, which is 23.0, created a socket module, which also met my needs. So it wound up being a huge but fun yak shaving expedition. But I really appreciated it. I learned a lot about how the Beam works. I taught myself parser combinators for this project. I learned a lot about Zig. I learned about how operating systems work. So no regrets. And I might in the future use this for some fast matrix math operations, TensorFlow bindings, CUDA bindings. The company I work for specializes in deep learning, so like this sort of thing might be interesting to me. Okay, so one last slide. I want to talk a little bit about the challenges of doing this. So again, like I said, the Beam has a dynamic type system. So marshalling between a dynamic type system to a static type system like Zig is a little bit tricky. I wrote a shim called beam.zig, which generally solves this problem for the specific Beam VM. And the other trick that I did was I parsed the headers or parsed the function headers and only allow certain types of headers into the system. Also, you don't want to cause memory leaks. Zig makes this easy with the defer and air defer directives, I guess. Again, the runtime can track the memory usage via a special allocator that I wrote called Beam Allocator, which takes the allocator interface in Zig and applies it to the one that is provided to you by the Beam. And non-challenges, Elixir LS integration. I wrote 0 lines of code for that. So you'll see that in a second. All right, so let's go to a demo. So first I'm going to create a new Elixir project from scratch. Let's go into that folder. Cool. Okay. So this is a folder that contains an Elixir project. Elixir gets pretty opinionated about how you should lay things out. And the key is this mix.exs, which is roughly equivalent to build.zig. It contains instructions on properties of your project and all the build information. And the key one that I'm going to do here is just add this one line, which adds the Zigler library into the depths. Okay, thanks for warning me, VS Code. And Elixir LS will just actually fetch that for me. Let's go into the project here. I'm going to delete some of this boilerplate that's unnecessary. And so let's take a look at this module. In the Beam, all your functions live inside of modules, and that's kind of an important thing to know. You can't have just a naked function floating around. And this function just takes is called hello and emits a symbol called world. All right, so let's look at that. This is the Elixir interactive shell, and so if I do, let's pull this down. It's got to do a little bit of compilation ahead of time. And most of these things won't be compiled again. The Elixir compiler is not as fast as the Zig compiler, I should say. Uh-oh. Great. Okay, so if I do zigshow.hello, it outputs world. Perfect. Okay, so let's add some code. Let's add some Zig code. And so to do this, you just add this. Use in my library, you use this directive called use Zigler. And so here, what I'm doing is I've written a function that will add the values inside of a list of integers and sum them together and return the total. So on first recompile, what Zigler will do is actually identify the most recent version of Zig and pull it down and then build a cache. So that is part of the reason why it takes a little bit of time to do this. I think I might actually be sharing my internet connection with my roommate, so who's doing something right now, which might be the reason why it's a little bit slower than when I tested this out before.
Well, you're also sharing your screen. Maybe that also has an impact.
Okay. So here it's done, and it says, hey, look, there is a compiler error. It expected this token semicolon and found 4 in code line 10. And so this is code line 10. And what do you know? Like in code line 9, I forgot to add a semicolon. So let's fix that. This might actually cause us. No, this will be fine. Okay, great. So now let's run this. And that's what you expect. So it's marshaled those values, those boxed values inside of the Beam VM, and turned them into a list or specifically a slice in Zig, and then perform the computation on that slice. So a couple of other things that I want to show. So note that we have this nif directive that indicates that this succeeding function is a nif, but there's also a doc string, and so internally it will actually take those Zig doc strings and turn them into Elixir docs for those nif functions, and it'll also produce the correct type spec for that function. So in this case, it's indicating that it expects a int32 ranged array. So specific, also importantly, as part of this difficulty between marshalling from a dynamic type system and a static type system, this is a perfectly valid directive in Elixir. If I instead pass something that isn't an integer, that's a perfectly valid type in Elixir. But what I do is I have an ingress check where it checks all of the values and makes sure that it's conformant with what Zig expects internally in its static type system. Okay, so how does this work behind the hood? Oh, actually, one thing more I do want to show. Oops. Is so here I've done all the type marshaling automatically. I can also do it manually. So my philosophy is that I believe that things should be explicit, should use magic when it's like a really difficult thing that's easy to get wrong. So everything else should be explicit. And you should always provide an escape hatch so that you can drop down and make things explicit when you want them to. So it's kind of like a restricted view on what should and should not have magic associated with it. So beam dot term. So beam dot term is a is the boxed term in the Beam VM. And so note that like as I change the code, I automatically get the Zig errors bubbled up to me from the Zig compiler. So we can fix this by using, oops. Oops. And that should cause this to disappear. Well, it might be a little bit slow. There we go. So it's recompiling this file just with explicit type marshalling instead of automatic type marshalling. And it still works. Okay, so how does this work under the hood? What happens is that Zigler creates a sandbox. And so first of all, that lives in the temporary directory. And so we can look at what the temporary directory looks like. Critically, there's this elixir.zigshow.zig, which gets created. That winds up getting compiled to this shared library. And that shared library gets shoved into a directory of assets. It gets put back into a directory of assets that the compiled program can use. So all this happens in a sandbox. Part of the responsibility of Zigler is to assemble common global files like beam.zig or this erlnif.zig, which is a wrapper for the header for the Erlang NIF headers, any includes that you want to have, and then of course a main Zig file. If you want to have other Zig files inside of your directory, your Elixir directory tree, you can also put them in there, and it will identify which ones it needs to import and put them into the sandbox directory. Okay, so let's take a look at this elixir.zigshow.zig. Okay, and so basically the way this works is that it gives you a couple of boilerplate headers. And then this directly here is the code that was inside that Zig code block inside of the Elixir. And there's a reference comment that tells me what the source file is and the line. And so that's how I'm able to translate errors that are emitted by the Zig compiler back into things that are relevant for Elixir LS, or Elixir and Elixir LS. So note that this isn't an export function, right? Because part of the key part of what has to happen is that I need to marshal in and out of dynamic and static type systems. And so as a result, I have to build, and I automatically build the truly exported functions, which I call a shim function, that handles all of the critical translations between the Beam and the Zig /CABI for whatever I want to write. So here, importantly, it converts a Beam term into a slice using this get slice of function. And of course, since it's in this Beam namespace, you can use it in your own code in exactly the same way if you wanted to do it manually instead of automatically. And then finally, there's a lot of what I call fiddly bits, which is like marshaling giving the Beam the information that it needs about what functions need to be imported. And then there's this monstrosity, which you can very easily get wrong, which is a descriptor for the entire collection of functions that you're sending. So you don't have to do this by hand. If you were to do this in C, you definitely have to do this by hand, and it's very easy to make mistakes. This is all done for you. It's all automatic. Your NIFs will just work, and I think that's kind of important. Cool. All right. So I do want to do one last mini demo. and we are going to switch into a pre-baked directory. So this is a project that mixes both Zigler and something called Nerves. And what Nerves is the embedded platform for embedded framework for Elixir. And it gives you a lot of really convenient tools to allow you to deploy to embedded devices, which I think is like really interesting. And in here, I'm going to also use Elixir's quote equivalent of comp time. It's not inside of a function, and it pulls a configuration value, which is this thing called the mix target, and I'll show you what it does later. But what is important is that it can select on what target you're deploying to at compile time. So here you can see that I'm actually grafting in different Zig code depending on what the compilation target is. So in the case of the host, I'll put the string disaster, and then in the case of anything else, it's going to create target says dumpster fire. And this is the Zig code that's going to get run. It's going to return a message based on the Gregorian year that you pass it. And you can see what's going on here. I've got a couple of convenience functions that help you make error tuples, which is one of the preferred ways of bubbling up errors in Elixir. So let's take a look at what this looks like on our host. Oops. Okay, so my function is called year, and it takes one value. And if I pass 2020, we get error, disaster, right? That's exactly what we expect. Okay, Larry, can you give me the name of somebody who's on like a screen name for somebody who's on the chat?
Yeah, sure. I think I want to give you the name of the latest follower. That's a very funny name. It's undefined_behavior.
Okay, that's great. All right, so let's do this. So I have inside of my computer an MMC card, and here's my Raspberry Pi. So I'm going to burn this new image. So it's recompiling, and this is going to the ARM. This is going to the ARM platform. Ignore that error. That's just a weird error that doesn't mean anything. I think it's happening because this is compiling. So I have told Zig to compile it as ARM, and it can't load that .so file because the architecture on my PC is x86, and so it throws that error even though once I deploy to the Pi, it's going to not be a problem. So, all right, so it's done. It's burned onto the card. I'm going to take this thing and drop it in here and plug my Pi in. So now we can see it's active. All right, so I'm going to ping the IP address that it should show up on with its Wi-Fi. It's still unreachable. Some blinking lights are happening. Okay, good. It's up. And let's SSH into it. And then let's do foo.year 2019. And if we do foo.year 2020, undefined behavior, rpi3 says dumpster fire. And so this really takes advantage of the cross-compilation capabilities of Zig. And I got to say, like, making this work was literally 3 lines of code. So, couldn't be happier about Zig. And yeah, that concludes my demo. And I'm up for questions.
Wow, that was an awesome talk. Thank you, Isaac. So before we switch into the Q&A view, I have one question. I saw that when you include Z code in a multi-line string in Elixir, you get the correct syntax highlighting. Is this something that is defined by Elixir? Is it something that you did hack? Like, what did you have to do to make that work?
I hacked it just for myself. It's you just have to like it's really you just have to like upload a 5-line JavaScript like file into VS Code. It's not that hard. Unfortunately, like publishing that on VS Code requires that I get a Microsoft Azure account, and I haven't done that yet. And so, I mean, if somebody else wants to do it, I can give them I'm happy to just donate that like those 5 lines of JavaScript, but I just haven't gotten around to making an Azure account.
Wow. Okay, so there's one question about the code, so I'm not gonna switch to the Q&A view. That's the one with only your webcam in it, because this one is about the code. So can you explain what the difference is between lowercase z and uppercase z?
Okay, great. So lowercase z allows me to do an interpolation from Elixir. So by default, you probably shouldn't do this most of the time. And uppercase z does not allow you to do interpolation. So this is like what you get. So as you can see, like the lowercase z is unhighlighted because I haven't added another 5 lines of VS Code to get that to work. But good question.
Okay, that's awesome. So
does that make sense?
Yeah, it does. It does. Okay, so let's start with the proper Q&A, and let's start with the first question, which is, when do you discover Zig, and how did you stumble upon Zig?
Yeah, so I actually remember when Andrew Kelly's like first video from the Recurse Center came out, and I was like, wow, this is a really good idea, but who the hell is this guy? Like that's what I remember thinking. And then a couple of years later, I came back to it, and I was like, hey, Zig is doing some really interesting things, but I really have no use for it, and I never picked it up. I think it was around the end of 3.0 and end of 4.0, beginning of 0.5.0, and then I really started working on this project around November-ish. I'm not entirely sure about that date, but that seems to be correct. And like in my head, but the Git logs will actually let you know when I started working on this. But yeah, this was my excuse to learn Zig.
Okay, that by the way, I think everybody, especially me, was blown away by how everything is super smooth and makes sense, and that's a very nice integration. So
it's almost as if the 2 languages are made for each other. So that's kind of what I feel.
Yeah, I guess so. I mean, that's when a dynamic language gives you all this possibility to interoperate with other stuff. That's when it really shines, right? You pay a price for the dynamicity and everything else, but on top of that, but in exchange you should be getting back flexibility, and when you have that, that's awesome.
Yeah, and I think like a lot of people get like really partisan about dynamic versus static, and I think like the domain that like this works at, it's really hard to get static typing correct for distributed systems. And like I think we really see this in the fact that like whenever you have even when you have something like statically typed programs deployed in distributed web services, your interchange format is like it's JSON that's like basically untyped, right? And there's like a good reason for that. And the Erlang team back in the 80s thought about doing static typing, and then they gave up on it. And That's not to say it's impossible. They're not like, they are not the end all and be all of what you can and can't do with distributed systems, but it's hard. It's a hard problem.
So let's see. A couple of questions. First one from Andrew. In what ways can the Zig project improve to better serve this use case? Is there anything else you would want to have there?
Oh, okay. I kind of anticipated this question, and I have like 4 specific things written down. Okay, so one is that I actually have test integration. I didn't show this off in this thing. I can run, if you write a test. I've also got integration where I will run the test inside of, and well, maybe I should just show it.
Okay, give me a second that I show you.
Well, actually, no. I think it'd be too. Yeah, no. It'll be a little bit tricky to set up. There's a lot of things that need to happen. But I can run the Zig tests, and they're similarly integrated into the Elixir unit testing framework. But it's a little bit of a hack. So I use my parsers, and I actually build a special version of the file where the test syntax is literally completely substituted. So I rewrite those functions to something that can be exported into the VM, and then it logs those as like Zig tests. So it knows which unit tests are Zig tests and which unit tests are Elixir tests. It's a little bit of a hack. I don't love it. And so if there were some way to like intercept tests, and this is a huge ask, and this is the most ridiculous of the asks. So don't make it a priority. But that would be interesting. Number 2 is having access to the Zig parser. So, or at least, so I have a series of like parser combinators that only look at the parts of Zig that I care about, and that's fine. It's a lot of code, and it's very hackish, and I would be happy to just throw that to the curb. And maybe there already is a way. I just don't know about it. But like just to get only the parsed like Zig information, like what's a type at comp time, what are the signatures of the functions, those sorts of things. And like I said, maybe there's a way to do that. I just don't know how to do that off the command line. 2 other kind of crazy things. One is escaping out of panics would be also useful for tests. If I could intercept when a Zig panics and just return that as some sort of like test value. I don't necessarily recommend doing that like at runtime for like real things, but it would definitely be useful for tests. And again, that's my reservation that some people might try to use that for like runtime rescuing, which I think is not a good idea. And then the Beam also has like a custom set of functions that allow you to spin up OS threads. And if there would be some easy way to allow the Zig async behavior to leverage that might be nice. But I actually am not sure that that's a direction that I think should be recommended for doing Beam stuff. I think you should maybe think about calling async directly out of your own, for various reasons. There's timing constraints on how long your function should run inside of the Beam. And I have a couple of escape hatches for that are maybe a little bit too in the weeds for this talk. But
whoa.
Yep, those are the 4 things.
Okay. Well, Andrew, we are looking forward then to 4 new issues on the project. I think the request, like I think it was your 3rd request about being able to handle panics in tests. I think this was discussed already because it makes total sense. Sometimes you want to test that the code properly panics, and yeah. Okay, let's see. Other questions. Could Zigler be used to support async Zig, which interacts with the Beam's scheduling in NIFs? I think you kind of hinted at that, but maybe you want to expand on it?
Yes. So okay. So the central problem is that Beam has a very like highly tuned scheduler for its way of doing things. So if your code runs in under a millisecond, it's probably okay. If you take a lot longer, maybe say more than 100 milliseconds for sure, you can cause like serious problems. So there are several ways around this. One, you can basically do a continuation, and I would love to figure out how to do that. But like understanding how the Beam does continuations kind of breaks my brain right now. Um, Another thing you can do is you can spawn an OS thread and run it inside of an OS thread. And it's currently broken in 0.3.0, but my next release, 0.4.0, will fix that. And it will let you do that automatically just by declaring, for example, I don't know if you guys can still see this screen.
I can switch to that. Give me a second.
Okay, yeah.
I think your screen sharing is not active anymore.
Okay, just by appending on the NIF directive in the doc string, the word long, and it will automatically spin up an OS thread for that particular function, and so that solves that problem. And then it would be cool if I could somehow also allow you to do async Zig inside of that, because that's now explicitly inside of the Zig ABI, right? But how that like interacts with like OS threads, os.thread versus the Erlang Beam way of doing operating system threads is needs to be figured out, basically.
Mm-hmm. Yeah, I don't know all the details, but given my understanding of how async await works in Zig, I think that what you are describing seems to be achievable to me because, for example, you mentioned that there is a time limit, right? A coroutine should not be running for more than a given amount of time. Well, there is like the way continuations work in Zig or async frames, they are able to, like, even as of today, the event loop has a way, allows you to yield. So you can, you would have to manually put yield statements in your code to yield at the right time, but then you would be able to do that. And I think coupled with the ability of bringing your own event loop, then the integration should be possible, assuming the interface, like we can reconcile the two interfaces.
Absolutely, yeah. Yeah, it seems like that should be possible, but like I said, like there's actually a lot about the Beam that I still don't know, so I need to learn that in order to figure out how to get that to work really nicely.
Yeah. So yeah, Andrew wrote a comment that makes total sense. Yeah, Beam would be the event loop, and so the yield would be provided by the Beam, and Zig would provide basically the ability of suspending a coroutine, which it does. Okay, that was an awesome presentation. Thank you very much, Isaac. Is there anything else you want to say before we move to the end?
I think I'm good. Well, thank you very much for having me.
Wow, yeah. Thank you for speaking. So let's now move to the end.